Good morning, good afternoon, good evening, good middle of the night, whenever you are watching this. This is lesson 4 of Unit 11, our redox unit. Today, the plan is to practice half reactions. So yesterday, we walked through what they were, how to write them, and I walked you through a bunch of different examples. So today is to practice that. And I'll talk about what that is in more detail in a second. So just so everyone's on the same page, it helps if you have the sheet that says half reaction practice out with you. So I'm going to walk you through the model example and then explain what your job is. It does look like you have a CAS learning due tonight on half reactions. So just make sure that that gets done and that you are following the calendar on the website and whatever other instructions your teacher may give you. So the sheet that you have for today has the whole sheet essentially is an example. And I'm going to walk you through that example. And then your job is to pick like 2 or 3, I think I said 3, different reactions and work through the same process. So again, this is not going to be collected. This is just for your benefit, but it does kind of review everything that we have done up to this point. So it's definitely a great review, and the answer key is posted for all these reactions, all these questions as well. So if you get stuck and or want to check yourself, that is the opportunity for you to, the place for you to go do that. So again, I want to walk you through the model and kind of model the thought process, and then you can use that to do as many as reaction questions as you want. If you do none, nobody knows about that. If you do all 8 of them, nobody knows, but great job. And then if you have any questions, obviously let your teacher, me, anybody know. So going over this model with you, the reaction that I decided to work with is this. Now this looks completely unfamiliar to you. That means you did not watch yesterday's video. Go back and do that now. Okay, so let's look at number 1. We know that iron is right here. It is going from 0 to a +3 charge. We know that because anything by itself has a 0 charge, and it literally says +3 at the end. And copper goes from +2 to 0. So with that being said, if oxidation numbers change, then it is a redox reaction, because that means something is losing electrons and then something else is gaining those electrons. Okay, so if our iron is going from 0 to +3, that means it is losing electrons. If you're losing electrons, you're becoming more positive. Now, copper, on the other hand, is getting more negative. That means copper is gaining electrons. If you think about it like this, think about, electrons being, they're negative, and if you have negative feelings and you're gaining, if you get more and more negative feelings, more and more negative stuff, electrons, you feel more and more negative and depressed. But if your, friend comes along, texts you, Instagram messages you, and you lose all of that negative feeling, you feel positive, you feel better. So with electrons, if you're losing electrons, you become more positive. If you're gaining electrons, you become more negative. Okay, so back to actual chemistry stuff. Number 3, identify which element is oxidized and which is reduced. So, pretty sure I've written this every single time since we've started it. Leo the Lion says GR. And again, that stands for loss of electrons is oxidation, gaining electrons is reduction. So, we had said before, for question 2, iron is losing electrons. So if you're losing electrons, that means you are being oxidized because the oxidation number increases because electrons are lost. Again, when you're losing these negative feelings, these negative electrons, these negative things, you become more positive. Copper, on the other hand, is being reduced because the oxidation number decreases, which means electrons are gained. So reduction literally means the oxidation number is going down, and it only goes down if you get more negative stuff, and the only way you get more negative stuff is if you're gaining electrons. Okay. Moving forward. Number 4, it says identify the oxidizing agent and the reducing agent. So here we said iron was being oxidized. So if something is, let's say, iron is oxidized, and copper is reduced. So I had mentioned this, I think the first day we went over this topic, the oxidizing agent, reducing agent. So whatever is being oxidized, in this case iron, is the reducing agent because it is oxidized. So whatever is oxidized acts as the reducing agent. So we know copper is being reduced because we determined that a slide or two ago. And then if it's being reduced, that means it is the oxidizing agent. Why? Well, someone thought this was a great idea to give them names that confuse you. Okay. But once you identify what's oxidized, then you know it's the reducing agent. And vice versa. Okay. So, let's write... Oh no, it got cut off. We're at the reduction one there. The oxidation reaction, half reaction, and the reduction half reaction. So we had said that iron is going from 0 to +3. That is oxidation. Copper is going from +2 to 0, which is reduction. And so this is exactly what we were working with yesterday. So for iron, it should look like this. Remember, you're always writing electrons as a product if they're lost due to oxidation. And your reduction reaction looks like that. And again, you always have electrons as products for oxidation. You always have electrons as reactants for reduction. We have 3 electrons lost because you have a +3 charge. They have to be the same. And you have 2 electrons here because you have to balance out the positive charge. Okay. So, moving forward, we have to balance them. So, right here we know that we have 3 electrons being lost, but 2 electrons being gained. So that is not okay. So that means we need to multiply, we need to figure out how to get the same number of electrons in both reactions. So the number the 2 reactions have in common is 6. So in order to get the oxidation reaction to give off 6 electrons, multiply it by 2. And then the way to get the reduction reaction to gain 6 electrons is to multiply it by 3. And again, this goes through everything. So if we go to the next slide, this is what it looks like after we have multiplied everything. Remember, iron got multiplied by 2, and now we have 6 electrons. And then copper was multiplied by 3, we have 6 electrons, and all of that. So, if you have the same number of electrons before and after, that's what you're aiming for. But you don't even need to write it in the reaction. So now if we're going to write out the complete combined balanced redox reaction, you write all of your reactants, 2Fe0 plus 3 copper 2 plus, and then all of your products. Again, order doesn't matter, Because if you think of 2 plus 5, that gives you 7, and 5 plus 2 also gives you 7. So as long as they're on the right side of the equation, it does not matter. So what I'm trying to say is, I could have written it like this, and it is exactly the same. Either one is fine. So that is your combined balanced redox reaction. And then number 7 is explaining, how you know it's redox, how you know it's mass is conserved and charge is conserved. So I'm not going to read this word for word because you guys are all capable of reading. But if we look at it really quickly, we have 2 irons on both sides, which is good. We have 3 coppers on both sides, which is good. The total charge of the left side. So if you have 3 positive 2 charges, that's positive 6. And if you have 2 positive 3 charges, that's also positive 6. So both sides have a positive 6 charge. And even though we got rid of them, one side lost 6 electrons, the other side gained 6 electrons. That's what also made sure everything else was balanced. So that is it for explaining the model. Again, there are 8 other equations you can work with. Pick as few or as many as you want. Work through the same process. Check yourself with the key. Make sure you finish the castle learning that is due tonight. And on that note, that is it. Have a wonderful day.